We're next going to start talking about function composition, which means you're putting the effects of one function onto or into another function. We're going to use the same functions as we used on yesterday's video, the parabola, the f of x function, the absolute value function g of x, and our graph h of x. Now the notation for function composition, one of the notations is this little circle doohickey thing here. This does not say FOG like fog. This says F following G, or last year in geometry, Mr. Sharp reads it as F onto G of 4. So recall last year you did this notation with transformations. Which one of these transformations would you perform first according to this? You would do the translation first. You would slide your figure to the right 4 and down 1. Then reflect it over the y-axis. So it's almost like you're reading backwards. You're starting from the right and reading backwards to the left, because the reflection is following the translation. That means the translation is in the lead, reflection is following it behind it. Same thing is true with our function notation. F following G, that means G is coming first, and then F is coming second. So the thing we're doing with G is we're plugging in 4. We're evaluating an input of 4 to see what the output is. So the absolute value of 2 times 4, take away 3. 2 times 4, take away 3 is 5. And the absolute value of 5 is 5. Now we're not done, because now we have to take that 5 and put it into the f function. We need to apply it to the f function. So we're going to do 5 squared plus 5 times 5 minus 6. 5 squared is 25, plus another 25 is 50, take away 6 is 44. And that is our final answer of f following g of 4. So when we plug in 4 into g, that answer into f, we come up with 44 as our output. Now the next problem off to the right there, I've switched the order to investigate if composition is commutative. Do we get the same answer when we switch the order? So g following f of 4 means we're going to take 4 and plug it into the f function, which is our parabola. So we're going to do 4 squared plus 5 times 4 minus 6. That'll be 16 plus 20 is 36. Take away 6 is 30. And now we're going to take that answer for f and plug it into the g function. So g of 30 is going to be the absolute value of 2 times 30. Take away 3. 2 times 30 is 60. Take away 3 is 57. The absolute value of 57 is 57. And notice we do not get the same answer as f following g. So composition of functions is not commutative. You have to do it from right to left. Now the other notation that can be used with function notation is just in parentheses, thinking about order of operations. So down below, f of g of negative 2, inside of the parentheses is the first function we're going to work with, g of negative 2. And whatever we get as an answer, we'll plug it into f. So g of negative 2, we're going to be doing 2 times negative 2 minus 3. Negative 4, take away 3 is negative 7. Absolute value of negative 7 is 7. Now we'll take that and plug it into the f function. So it'll be 7 squared plus 5 times 7 minus 6. 7 squared is 49, plus 35 minus 6 is equal to 78. And now lastly, we've got a function composition involving all three of our functions, g, f, and h. We're going to start with the innermost parentheses, h of negative 2. So our h function is coming from our graph. On our graph, when I go to x is negative 2, the y value, or the output, is at 1, 2, 3, 4, 5, 6. So h of negative 2 is 6. Now we'll take answer of 6 and plug it into the f function. So this will be 6 squared plus 5 times 6 minus 6. That'll be 36 plus 30, which is 66. Take away 6 is 60. And then we'll take that answer and plug it into the g function. So g of 60 is going to be the absolute value of 2 times 30. Take away 3. 2 times 30 is 60. Take away 3 is 57. Absolute value, I'm plugging in 60. So this should be 2 times 60 is 120. Take away 3 is 117. Absolute value of 117 is 117.